Welcome to class. How are you today? Yes, we still want to continue with the topic electrolysis. Today we want to be looking at the factors that affect or determine the discharge of ions during electrolysis of aqueous ionic compounds. Selection of ions. In our last class, I told you we analyzed some electrolytes. We analyzed those of them in molten, and we said once they are in a molten form, there are just two ions, one positive and one negative. Molten in the sense that the compound is there, it's not being dissolved in water. If I have molten lead 2 bromide, I only have two things there. I only have lead 2 and the Bro minus. Okay, this compound is not dissolved in water. It didn't put it in water, no. So this goes to the negative electrode and this goes to the positive electrode. Then we discuss the aqueous. Aqueous. Imagine we have ionic compound that can dissolve in water. Because an electrolyte is the ionic compound that is in solution or molten. Now, for the solution, how do you make it to be a solution? By dissolving the ionic compound in water. So if actually it is dissolved in water, as we stated in our last class, what will happen? The compound itself produces 2 ions, while the water does what? Also will produce 2 ions. One positive, one negative. What will happen? If 2 positive move to the negative electrode and 2 negative ions move to the what? Positive electrode, which one will leave, will be discharged, which one will be selected, move out, and which one should return and they still become part of the electrolyte inside the electrolytic cell? That is why we are here today. When you pay attention, you will understand that there are a set of rules or factors that will help us to know which one is moving out and which one is staying back. Okay, looking at the first I have on the slide, it's a factor that affects or determines the discharge of ions in electrolysis of aqueous ionic compound. Now, in the preferential discharge of ion, 2 negative ions migrate to the anode. Why? Anode is a positive electrode. Where one of the 2 is selected based on some factors which we are about to discuss. Also, 2 positive ions migrate to the cathode because cathode is a negative electrode. Where one of the 2 is selected based on same factors. These factors that tells us which ion is selected from each of the electrodes are. These are the factors we want to discuss today. The first one is position. The position of ions in the electrochemical series. In the electrochemical series. The position of ion in the chemical series. Sorry, the clothed ions should be part of the negative part. This position is actually, looking at what we have on the slide, I will give you here a comprehensive electrochemical series of the positive ions and that of the negative ions. Okay, so let's look at position of ion in the electrochemical series. I'm going to write electrochemical series for the positive ions and that one for the negative ions. We now look at how their position can help us to know which particular ion that will move out and which one should actually go back and stay in the electrolytic cell. Okay, now the positive ones are, I have potassium first. I'm going to use, okay, I have sodium, I have calcium, I have magnesium, I have zinc, I have iron ferrum, I have tin, Sn 2 plus, I have lead, plumbium 2 plus, I have hydrogen plus, then I have copper 2 plus, right? Copper, I now have mercury, silver, and gold. Mercury is Hg, silver Ag, and the gold Au. These are the positive ones. Now, the negative ones, we have fluorine, which is the most reactive. Sulfate ion, SO4 2 minus. Nitrate ion, NO3 minus. Chloride ion, Cl minus. Bromide ion, Br minus. Iodide ion, I minus. And hydroxide ion, OH minus. These are electrochemical series. These are what we call electrochemical series. These are the positive ions, and why these are the negative ions. Now, one of the factors that will help us to know the ion that will be discharged, leaving the one behind, is this electrochemical series. So, now, which one should be discharged? Imagine I have sodium is involved and I have hydrogen is involved. The electrolyte contains sodium ion, hydrogen ion, two positive ions. And both of them being positive move to the negative electrode, which is the cathode. Which one is discharged? Now, looking at this position, the one that should be discharged, that means the one that will pick electron and become neutral atom, is the one that is less reactive. Is the one that is what? Less reactive. You can see it's very simple. So between the potassium, sodium there, and the hydrogen, the one that is less reactive is the hydrogen ion. Because as you move down the series, the reactivity is decreasing. The reactivity is decreasing. Potassium being the most reactive, while gold being the least. So preferential discharge of ions move in this direction. Watch it. It's increasing. As you go down, there is what? More tendency of the ions below to be what? Discharged, leaving the electrolytic cell, while the other one at the upper side, the one that is more reactive, will stay back. So can you now see that in the electrolysis of aqueous compound, where sodium is and hydrogen, both of them are positive, in as much as hydrogen is less reactive, considering the position here, hydrogen ion will be discharged, will be finally being neutralized, being collected as hydrogen gas at the cathode. Let's look at the negative side. Let me assume that the compound is between chloride ion and OH minus. Remember, the OH minus is actually coming from water, while the hydrogen ion in the positive side is coming from water as well. Now, if I have chloride ion here, look at the chloride ion and OH. Which one should be discharged? The one that will be discharged here, considering the position, if every other factor should be kept constant at the moment, the one that should be discharged is OH. Remember, the line I drew is for both sides. As you move down, the one being discharged is coming from the what? The one that is less reactive. So this is increase in preferential discharge of ions with the direction of this arrow. In other words, the ones that are less reactive are discharged in preference to the ones that are more reactive. If you know, of course you are aware that fluorine is the most reactive non-metal, especially in the first 20 elements. It's very reactive. So the one that is less reactive should be discharged in preference to the one that is more reactive. This is true for both the positive and the negative part of electrochemical series. Having said this, we are going to look at aqueous electrolysis of aqueous sodium chloride. Dilute, look at the word I use, dilute sodium chloride. Aqueous, dilute aqueous sodium chloride. That is, the sodium chloride has been dissolved in water, one, and is also well diluted. We shall see which one will be discharged finally at the anode, which one should be discharged finally at the cathode. Because at the moment where the current is passing through, at the moment where you are passing the current through the electrolytic cell, there are 4 ions, 2 positive, 2 negative. So the 2 positive ions are actually competing. Which one should go out and which one should remain? So I will be using sodium chloride now. I want to believe you have actually picked this electrochemical series. Now, let me now use a compound which is an ionic compound and also in aqueous form, dissolved in water. So, electrolysis of aqueous sodium chloride, dilute aqueous sodium chloride. Let's look at what happens. This is the electrolytic cell. This is the anode. This is the cathode. This is the source of current. Here we have sodium chloride dissolved in water. Sodium chloride dissolved in water, so it is aqueous. What does that mean? It means that the sodium chloride has been dissolved in water and is well diluted. So let us bring out the 2 compounds that are involved that should be seen here. What are those 2 compounds? The first one is the ionic compound, which is sodium chloride. How many ions? It has sodium ion positive and chloride ion negative. Let me have that of the water. The water have H plus positive and the OH minus negative. Look at it now. We want to determine which one should finally be gotten as a neutral element and which one should go back in the electrolytic cell. I want to believe you are following these steps. Now, between these 2 that are positive, where will they go to first? They will move to the negative electrode, which is the cathode. So we want to see what happens at the cathode now when both of them get to that cathode. What happens? one wants to be discharged and or two of them want to be discharged. So which one should move out? Now look at sodium and hydrogen. Which one is less reactive from the electrochemical series? The one that is less reactive is that of hydrogen ion. So hydrogen ion is discharged. What do we mean by hydrogen ion is discharged? What we mean is the same way we analyze electrolysis. The same way, so H plus at the cathode. Cathode, what happens is what? Reduction. We'll gain electron that will cancel out this hydrogen ion, that is E minus, so it can give you neutral what? H. Have you seen it? But because hydrogen is a gas, is a molecule, diatomic molecule, it has to occur like this, 2. Because of these 2, you have to balance it by the other side, 2. That means if you should interact this plus with this, you'll be having plus 2. So you can't use only one electron to cancel plus 2. Rather, you need 2 electrons. So minus 2 plus 2 will give you 0. That means hydrogen gas is produced at the cathode during the electrolysis of what? Dilute aqueous sodium chloride. Dilute aqueous sodium chloride. The product that can be gotten at the cathode is hydrogen gas. What happens to the other positive ion, sodium ion? We move back inside the electrolytic cell. Yes, to go back into the... Okay, that is understood. Now, let's move to the negative part. I have chloride ion negative and I have OH minus. I'm done with cathodes. So this equation can be referred as cathodes half equation or cathode half reaction. Okay? Where finally hydrogen has been discharged, treated, and is collected as a hydrogen gas. So let us go to the anode. What happens at the anode? First of all, what charge does the anode carry? The anode carries positive. So the 2 negative ions inside the electrolytic cell will move there. So let's look at what happens at the anode. These 2 are moving there. Cl minus and the OH minus. Both of them are negative. So which one should be discharged? Which one should lose or gain electron and get discharged? And which one should go back? Keeping other factors constant. Positioning our mind on their position in the what? Electrochemical series. From what I wrote on the board, between OH minus and chloride ion, which one is less reactive? Is OH minus. OH minus. So the one that is less reactive is discharged. Therefore, we are going to write the anodic half reaction equation using the OH minus. Can you see that now? So I will now have, pay attention to this because this one will take like up to 3 steps. I have OH minus. This is taking place at the anode. What happens at the anode? I keep saying it. Oxidation takes place at the anode. What is oxidation? Is loss of electron. That means when OH gets to the anode, the OH loses electron. For it to lose electron, it should produce the neutral form of OH, which is ordinary OH. So this minus will appear here in the form of electron, which is E minus. Can you see that? Now the reaction continues. This you must take your time to study. So now OH will join with another OH to produce water molecule plus oxygen. And finally, oxygen cannot stay this way. Oxygen is a diatomic molecule. One atom of oxygen combines with another atom, finally giving you what? Oxygen molecule. But we actually need a simple, straightforward equation that collects every necessary thing in these 3 equations. We need just one straightforward equation. So we are going to start from where the reaction started. The reaction actually started from OH minus. Where are the products finally? The products are water and oxygen. Yes. The essence of this OH joining 2 times to get water. So I have water here, and after this, I also have oxygen. So the 2 products here are what? Water molecule and the oxygen. Now, we have to balance this equation. We have to balance this equation. Let me write it where we have to balance it in terms of atom, in terms of charges. This is exactly what we did in balancing of redox equation. So I have now OH giving me water, then plus oxygen. The question is, can you see minus here? Can you see minus? Don't forget the minus will have to cancel out by putting minus there, which is the electron we'll have here. So this electron will come in also. Now, let's balance in terms of atom. I have how many oxygen here? 1. Here I have 3 oxygen. So making it an even number, if I put 2 here, I will have 2 atoms of oxygen here plus 2 at my right hand side, which gives me a total of 4. That means I will be having 4 by the side of OH. Having 4 at the side of OH, what do I have now? I have 4 interacting with minus, which is minus 4. That means my electron at my right hand side will carry what? 4. So let's check oxygen. Oxygen is 4 here, 2 here plus 2, 4. So the equation is balanced in terms of atoms and in terms of charges. In fact, these 3 steps, nobody will ask you about it. All you need to know is the last equation there. Whenever, listen to this, whenever OH is discharged, whenever hydroxide ion is discharged, this is the balanced equation. I repeat, at the anode, whenever OH minus is discharged, the complete balanced redox equation is 4OH minus giving 2 moles of water plus 1 mole of oxygen molecule, then plus 4 electrons. Plus what? 4 electrons. Take note of this. Plus 4 electrons. So you can now see that the position of the ions in the electrochemical series has a lot to do with what? The preferential discharge of ions during electrolysis, provided the other 2 factors we are going to discuss are kept constant. So this is what happens during electrolysis of dilute aqueous sodium chloride. What are the products produced? What are the substances produced? At the anode, oxygen is produced. While for that of the cathode, hydrogen gas is produced. So what happens in the electrolytic cell? 2 things are remaining there. Do not forget that OH actually competed with what? The chloride ion. Right? Why the sodium ion actually competed with what? Hydrogen ion. Now, finally, this one moved out and finally gave us oxygen. And this one moved out, between this and this one moved out and finally gave us hydrogen gas. So the 2 things that can be found inside the electrolytic cell after the electrolysis of aqueous dilute sodium chloride are still what? Sodium chloride. So that means you can as well produce this chemical, sodium chloride, using the electrolysis of the same sodium chloride, the aqueous one. Originally, you have it, but at the end of this electrolysis, you get oxygen, you get hydrogen, and you still have the compound itself inside the electrolytic cell. What is happening there? The whole process found inside the electrolytic cell, there is a conversion of electrical energy to chemical energy. Because at the end of the process, chemicals are produced, either in the form of compound or in the form of elements. So can you see, taking position of the ion in the electrochemical series, one that should be discharged in preference to the other. Okay, now I will use another. Okay, that is understood. That is understood. You check the positive side, check the negative side. You know, the positive side, the two of them, the one that is less reactive will discharge, while the one that is more reactive will remain. The same thing is applicable to the negative side. Having said that, let's quickly go to the next factor. The next factor that will tell us which ion is going to go out and which ion will remain. That factor is how concentrated the ion is. The concentration of the electrolyte. The concentration of the ion. The concentration of the ion. I want to still use sodium chloride. Remember, the first one we did, we used dilute one. And that was why this factor we're about to discuss now was kept constant. Now, the same sodium chloride, we shall be discussing it when it is concentrated, when it is not diluted. I am still using sodium chloride. It is aqueous, of course. It is aqueous. It dissolved in water, but it's being concentrated. Concentrating it, what does that mean? You have less water. Yes. Dilute, what does that mean? You pour more water. So we are done with the dilute one. Now, we want to look at that of the concentrated form of sodium chloride. We want to look at the concentrated form. I am still making use of the electrolyte, sodium chloride. Sodium chloride. Aqueous. But the aqueous form of it is concentrated. So the electrolyte is concentrated. And what does that mean? The ions are also concentrated. So that is why we look at it as another factor that will help us to know if actually this ion is going out instead of the other. Now, if it is concentrated, what happens? Does it change? Let us still produce the ions that are present. The four ions are, the two positive ones are what? Sodium ion and hydrogen ion, because it is still aqueous. And the two negatives are what? Chloride ion and what? OH what? Minus. Okay, looking at the concentration of the ions, it affects that of the negative side. Doesn't affect here. So it means that the one that should still be discharged at the positive side is that of the hydrogen. So we still get hydrogen molecule as a gas at the end of the electrolysis of what? Concentrated sodium chloride, right? But at the negative part, because it is concentrated, it's no longer OH that will be discharged. Considering its position in the electrochemical series, it's no longer OH. Rather, the what? The chloride ion, because it's part of the compound that is being what? Concentrated. Take note. Ordinarily, if it is diluted, OH will, take note of this, all the aqueous form of electrolyte you will come across, as long as it's not concentrated, OH will always be discharged, producing oxygen, 1 mole of oxygen at the end of the reaction. But if you are told that that aqueous solution is concentrated, then the other ion would be the one to be discharged. So in that case, at the cathode, it remains the same. This is the cathode, which is the negative electrode. These are the ones that will move there. Getting to that point, this is discharge, because this is less reactive. Do not forget, in the position of the position of ions in the electrochemical series, we are looking at those ones that are less reactive. Below, they are the ones to be discharged. When you look at sodium ion and hydrogen ion, you will notice something. That hydrogen ion is less reactive. What are you going to expect? You expect that hydrogen ion will be the one to pick the electron, one electron, to become neutral what? Hydrogen. So this will cancel like this. But if you leave it like that, it doesn't show maturity. The hydrogen will now occur as a diatomic molecule. So because of these two has to come in here. Because of these two that will interact with the plus, two has to come in here. So it's balanced. So the same thing that happens in the first one we did, nothing is changing. This concentration does not affect the positive side. So hydrogen gas is still produced. So what goes back into the electrolytic cell? That of the what? Sodium ion. Now, coming to the negative ions, the concentration of the ion will have effect. In that case, instead of the OH being discharged, what will be discharged is what? Chloride ion. So the reaction actually taking place at the anode now will be chloride ion losing electron to produce chloride what? Atom, right? So which is one electron. So chlorine is also a diatomic molecule. So if I will have two here, I will have two here, and the two will come in here. So which gas is produced at the anode when the electrolyte is concentrated is what? Chlorine gas. So around the anode, if here is positive anode and here is negative, around the anode, you will notice a gas here, which has like a green color or yellowish what? Green will bubble here. Okay? While at the cathode, which is negative, the gas that you find there is what? Oxygen. Oxygen, you notice a colorless gas because oxygen is what? Colorless. Once OH is discharged at any time, once OH is discharged, please, it will only be oxygen gas. But once it's not OH, any other thing can come. Like this one now, chlorine is discharged. So chloride ion is discharged. So we are getting chlorine gas at the anode, which is this. At the cathode, between sodium and hydrogen, we said that hydrogen is less reactive. So finally, we'll get hydrogen gas at the cathode. So here is hydrogen gas, not oxygen gas. Here is hydrogen gas, which is also what? A colorless what? Gas. Which is also a colorless. So that is how we consider an electrolyte that is concentrated. I repeat, the one that is concentrated only affects the negative ions, right? Instead of OH being discharged, the other ion is discharged. Take note, this effect can only be possible when these two ions are very close, are positioned closely in the electrochemical series. That is where the concentration will have effect. If they are far apart, it may not have effect. Okay. Finally, the another factor is nature of the electrode used. Nature of the electrode used. When these are the electrode, electrodes can be inert, electrode can be active. If an inert electrode is used, no problem. Every other factor we have discussed will move that way. What are these inert electrodes? The inert electrode we have are the carbon or graphite, which is a form of carbon, the platinum. These are inert electrodes. These are what? Inert electrode. Inert electrode. Like, some electrodes do not take part in the electrolytic reaction. Such electrodes are called inert electrodes. Examples of inert electrodes are platinum, carbon, or graphite. Once they are there, once you are told that here and here are made up of platinum, graphite, carbon, you don't have any problem. Other factors will be considered. No problem about that. But the moment an active electrode is used, a situation where these electrodes are not made up or are not being constructed using graphite or platinum or carbon, but they are not constructed using copper, then something has to be done. They will be involved in the electrolytic process. What happens? What will happen now is this. At the anode, if you use copper, the copper will dissolve. Okay? The copper will dissolve. Just one example to round up this. If I have copper 2 sulfate and this electrode is made up of copper, maybe this one is made up of another thing, even if it's copper, no problem. Let me use platinum, or let me assume that this one is what? Inert electrode, or even copper as well. My interest is the anode, here. If here is very active, it will affect the electrolytic process. How will that take place? Remember, here we have copper 2 and we have SO4 2 minus. Because it's aqueous, we have water which produces hydrogen plus and what? OH minus. Can you see that? These two are what? Positive. Where will they go to? They will move to the negative what? Electrode. Which one will be discharged? Copper, because copper is less reactive than hydrogen. So copper now will pick 2 electrons, copper 2 will pick 2 electrons there to become neutral copper. Right? These two, where are they supposed to be going to? They will be supposed to be going to the positive, which is there. But because what is here is copper, which is active electrode, these two will remain inside this place. Rather, this copper, which is here, where the electrode is made or constructed using copper, what will happen? That copper solid will now, this copper solid here, will dissolve inside this place to produce copper 2. Can you see the difference? Once an active electrode is used here, active, watch, this copper has something to do with the electrolyte. The electrolyte is copper 2 sulfate, and the electrode is copper, very active. The copper being solid, as current is passing through, will dissolve inside this place to produce this. So it has to be balanced by putting what now? 2 electrons, so that this and this will cancel out. But if here is not active, it's just platinum, graphite, carbon, no problem. Our normal electrolysis continues to take place, considering other 2 factors, which are what? Position of ions in the electrochemical series, and the data of the what? How concentrated the ions are. Having said this, we have come to the end of this part of the lesson that deals with factors, how to know the selection, the discharge of ions, the ions that are discharged, a preference to the other, having known or having considered that there are 2 positive ions and there are also 2 negative ions. In the next class on this electrolysis, we shall be looking at the Faraday's first and second law of electrolysis and the calculations that are involved. Till then, bye.